Okay, so for section 10.3, we're going to use relationships of arcs and chords in a circle. To use relationships of arcs and chords. So we're going to kind of be looking at how do the chords and arcs correspond, how do they relate, what's the same, what's different. So the first theorem says, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if you look at the picture given to you, they've marked these two chords congruent. They're obviously in the same circle, so then we would know that BA, arc BA, is congruent to arc CD. Now, for your first example, there are two different circles, but right here where they put these tick marks on this radii, that shows you these are congruent circles. Okay, so it says BC is congruent to EF, so you got your congruent chords, and EF is 125. They want the measure of BGC. So this one has a little extra step. You know, if this is 125 and is congruent to this, this has to be 125. And then to find that major arc over here, we know a full circle is 360. We just take off the 125. So we get 235 degrees for that one. All right, this next theorem says if one chord is a perpendicular bisector to another chord, then that first chord was a diameter. Okay, so if one chord is a perpendicular bisector of the other, so that's where some people were kind of messing this up just a tiny bit. You have to figure out which one's doing the bisecting. So this one would actually be doing the bisecting because you can see the two congruent pieces here. So we then would know from looking at this picture that SQ is a diameter, and obviously that's going to become important because then we know semicircle and we know 180. So if a chord is the perpendicular bisector of another chord, it is also the diameter. Now, theorem 10.5 is very similar. It says if a diameter of a circle, so here's your diameter right here, whoops, is perpendicular to any chord, then the diameter bisects the chord and its arc. So it makes these two pieces congruent, and it also makes the two arcs out here congruent. So if a diameter is perpendicular, which they mark, to another chord, it bisects the chord and the corresponding arcs out here. So let's look at this example 2. It says use the diagram of circle E to find the length of BD given that FB is 4x plus 5 and DF is 6x minus 9. So what do I know? This is a diameter. I know that because it's going all the way across my circle and it's going through the center. So because the diameter is perpendicular, I know these are congruent. So you're just going to take these two measures, 4x plus 5, set them equal to each other. So it's going to give me 2x is 14 and x is 7. But this said find the length of BD. So to find this whole segment, I just need to plug this into one of these. It doesn't matter which one. I'll go into this one. 4 times 7 is 28 plus 5 is 33. But then I have to multiply that by 2. So the answer to this one should have been 66. Okay, if you look at example 3, same thing. Use the diagram of circle E to find the value of x. So here's your diameter. We see this little right angle marked, so we know these are congruent. So we're going to set 6 equal to x squared plus 3x minus 12. So this is the same exact concept as the problem up above, but obviously this one is just a little more algebraic. It's a quadratic. We've been working with these all year. Make sure you get this in standard form first by subtracting the 6. So that gives me 0 is x squared plus 3x minus 18. Can factor that using the x method. So what adds to give me 3 but multiplies to give me negative 18. So that's going to be 6 and negative 3. So we end up with x plus 6 times x minus 3 equals 0. So we get two answers, x to be negative 6 or x to be 3. And I think they actually both might work. Let's plug in negative 6 right here. So if we do negative 6 squared plus 3 times negative 6 minus 12, that gives me 36 minus 18 minus 12. Is that equals 6? And it does. So these actually both work. Because this negative number didn't make a negative segment. So that's why it worked in that situation. Okay, last theorem here. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant. It's kind of a big word. From the center. Okay? Equidistant from the center. So right here, if we know that these are the same length, so it's showing me these two chords are the same distance away from the center, then we know these chords are congruent. And then it also works the other way. If you know the chords are congruent, you know these little pieces from the center have to be the same. So if we look here on this example, it says if A, B, and CD equal 12, so you know the lengths of these chords. So immediately, when I know those are congruent, boom, I know these are congruent. Okay, and then it says if GF, this little piece is 7x minus 8, and EF is 3x, fine. So we know that these are congruent then, 7x minus 8 and 3x. That's going to end up giving me 4x equals 8, x is 2, but it says to find EF. So I'd go 3 times 2, and that would be 6. Okay, last one. In this diagram, it tells us that GF, it tells us these little two pieces are congruent. So immediately I know these chords are congruent, A, B, and C, D. So again, it says AB is 3x. We're going to set that equal to x squared plus 5x minus 35. So again, this is a quadratic. So first things first, we're going to subtract 3x from both sides. We get 0 to be x squared plus 2x minus 35. So we're going to factor this. What multiplies to give us negative 35, but adds to give us 2. It's going to be 7 and negative 5. So 0 is x plus 7 times x minus 5. So x is negative 7 or x is 5. In this case, this negative number does not work. So like if you go to plug it in right there to AB, 3 times negative 7 is negative 21. Okay, so that's not going to work. Now, I know it says define CD, but I know that CD and AB are congruent, and it's way easier to plug into this equation. So I'm just going to plug it in there, and you should get 15. Okay, you obviously could plug it into this longer equation, and you would get the same answer.